So I used to start my class by just diving into like my work or diving into all the inspiration materials. And then people would stop me and be like, wait, what do you do? Like, what kind of things are you working on? So I begrudgingly now introduce myself and my work. I'm Derek Schultz, obviously, like you signed up for this class. I hope you've at least seen some of my work before just diving in, but maybe not. I'm a product designer at MailChimp, actually. So I'm here in Atlanta this week, which is where MailChimp is based, doing some work. But outside of my product design work, I have worked a lot in machine learning. And it's sort of funny, I realized this week that about 2 years ago, I took a class at SFPC, which is the School for Poetic Computation. It's in New York City. It's run by Zach Lieberman and a couple other great people. And I took a class not unlike this class, where it was sort of a deep dive intensive into machine learning. It was a full week it was like 3 hours every night. It was very, very intense. And then it was all weekend after that. So it was literally almost about 2 years ago this time. Every session was taught by one of these people. And I'm not going to talk about every one of these people, but like, if you're really, really interested in machine learning, you should look up these people's names. Every one of them makes really interesting artwork or is a critical theorist like Momo. Like every one of these people is working in machine learning and is doing really interesting stuff. In particular, like the work that I learned a lot from was Gene Kogan. He runs a thing called Machine Learning for Artists, which if you haven't seen, I definitely recommend looking that up. I teach like a very narrow set of what he teaches. And I go a little bit deeper into some of the image making stuff. But I learned from these folks. So like when I was talking about approaches, I took the last approach with this class, which is I like was in the session for like a week long intensive. It was super intense. I took like 3 months off because like it hurt my brain. And then I came back and started working on it. So actually some of the stuff that I made was this. So actually this thing on the right is from Julie. Julie sent me some of her style images, and I like applied some style transfer stuff. And then the thing on the left is an old thing called of an old version of a GAN, which I might talk a little bit about. But like, so this was my work like about 1.5 years ago. And now I'm producing work that looks a little bit more like this. So this is a piece I did for Baffler magazine. And this is a little bit more of a process piece. So like the image I found online on the left, I then converted into the thing in the middle in Photoshop, and then I did a style transfer on top of it. So this is sort of like what we might talk about is like how an artist might work using these tools, right? So this is literally a tool chain where the last part of it is a neural network and machine learning. So literally like this is kind of the work I make now. This is another illustration also for that same Baffler magazine piece, where again, I'm sort of manipulating machine learning images, but then bringing them into illustrations or into Photoshop pieces. So it's a little bit of like not pure machine learning art, but like mixing it up a little bit. And I'll talk a little bit more about like why like I think that approach might work for some of us versus other approaches. And then lastly, I keep saying lastly, I don't know why. Anyway, I'm really, really excited to have Leah join. This is actually the first class where we have a TA. And I think Leah's gonna do a great job with this. So I'm gonna let her introduce herself.
Okay, hi everybody, I'm Leah. Next slide. That's me. Yeah, next slide. So I'm based in Seattle. I have always made art my entire life, but I was also, my bachelor's was in computer science, and I've been kind of like a programmer also simultaneously my entire life. I recently, or about 6 months ago, quit my job to focus full-time on artwork and like bridging together those two interests. So I quit and went to School for Poetic Computation in the fall. Just finished a session about a month ago, and then that is me on one of the last days at SFPC. Next slide. And soon after that, also since after leaving my job, which I was, at my old job, I was doing machine learning work for about 1.5 years. I started doing work with a university on generating images with GANs for the purpose of making artwork. And so I presented at a conference in mid-December called NeurIPS, which is it's a big machine learning conference. But they have this nice little workshop inside of it called the NeurIPS Workshop on Creativity. which is a workshop devoted specifically to the usage of machine learning and AI for creative purposes. So we had like musicians and visual artists and performance artists there, as well as machine learning researchers. And it's just like a really good nexus of people. Gene Kogan was there as well. And so these images here are 4 images that came out of the network that I trained. Yeah, and happy to talk more about this work too, if you're interested. Yeah.
Thanks, Leah. Yeah, and if you're unfamiliar with NeurIPS, like it's pretty much like the machine learning conference. So getting to present there is pretty amazing. And honestly, Leah should probably be teaching this class instead of me. But we're really lucky to have her. And I think she's gonna be a huge help for the remote version of this class. So thank you. Cool. So I want to do a project really quickly. I get the sense that like all of us are sort of sitting at our computers, like hanging out, and I'd like to get us a little bit more active. So what I want you to do is I want you to think of a sentence, and I'm going to leave it as ambiguous as that. So write down a sentence and post it in the Zoom chat. I'll give everyone like 2 minutes to think of a sentence because I don't want it to be like, I don't want to give you too much time. So if you've got your sentence, stick it in the Zoom chat. Julie, I feel like you know what I'm going to do here. So like you're cheating. Maybe we'll see. So Leah, why don't you pick a sentence that I should put in here?
I do not love this because I was expecting piano. I'll try it again when I'm not. From David.
All right, awesome. So this is Runway. We'll talk a little bit more about Runway at the end of the class, but I want to just quickly jump into this and experiment with a little bit. We're going to use a machine learning model called AttnGAN. And what it does, it converts a sentence into an image. So I'm going to go ahead and start running this. Should take just a minute to get set up. Cool. So when I put in a sentence, it's going to start generating an image. So that's pretty interesting. I'm going to save these because I love posting them online afterward. I'm going to pick one more. I'm actually going to pick Julie's and see what happens here. I think this is really interesting. This is an interesting question. Okay, I'm going to pick another one. I'm going to try Jessica's. Okay, and now I'm going to try one, and we'll see if I get different results. So wow, I feel like the first one I had there was way better, and I lost it. Oh, what did I have? Space? There we go. That's what it was. Okay. Okay, so I'm interested in hearing, like, if a couple people want to talk, what did you think about those images? Like, what was interesting to you, or what did you find unique about them? I can call on people if I have to.
I was going to say, I thought it was interesting that you can run the same one repeatedly and you get different images. Like it's not an atomic representation. Like it kind of changes each time.
Yeah, so I actually think what it was is it is what's called deterministic, which means it's static. But the difference is, like, if you had a space at the end, you get a different image than if you don't have a space at the end. So it is like, and also if you reverse these, so the beach um, laid a dog. This isn't even a sentence, but it's like something. Okay, that's interesting. Yeah. So yeah, it is like it changes a little bit depending on how on the variations. Yeah. Anyone else?
I like that spatially nothing makes sense.
Can you talk a little bit more about that?
Like things don't occupy space in the way that you're expecting them to. Either, like, for example, the dog stretched out on the beach is taking up too much space for what it's supposed to take up, and other things kind of spill out, and like things don't connect to other things in some logical way.
Yep, totally. Anyone else? Okay, cool. So I think what Juliet said is really interesting, which is that, like, she gave it a very nice presentation, which is like, spatially it doesn't make sense. Whereas my response would be like, this sucks. This thing, like, doesn't do what I would expect it to, right? Like, and this is what I think is really important to understand about machine learning is, like, in general, these things are not great. Like, you hear all this stuff about in the world that, like, oh, AI is going to take your job in 5 years. AI is going to do this, that, or the other. And, like, this is a pretty significant artificial intelligence model in that it converts text to images. And, like, that's something that you or I could do pretty much, like, in a heartbeat, right? Like, if I say a sentence, you can visualize it, right? So if I say there was a car near the beach, you can create a visual in your head that's, like, pretty straightforward and connects really easily. These models suck. They don't do that. And so, like, part of what I think is really interesting is I was surprised by what images made sense, like using the sentences we had, and then what made, like, what I was putting in as the default, like, here's a dog on a beach, and how you got a dog-ish thing and you got a beach-ish thing. And part of that is understanding how the model was trained, right? So I'll talk a little bit more about Runway in a little bit, but, like, if I were to look up this model and I go here to click on learn more, it's going to tell me a little bit about what the model is supposed to do. But more importantly, at the bottom over here are what's called code, paper, and more. So you can actually click on this and you could go to the research paper. This is the research paper that a bunch of researchers put together that describes how AttnGAN works. And you'll see, like, what it does is it's trained to look for certain words, right? So it looks for red, it looks for this bird, and it tries to train these things, pulling the image representations out. And of course, if you, like, scroll through this paper, you'll see a lot of math, which we will not discuss at all in this class. I couldn't tell you what any of the math here means, but they also have a bunch of examples. And what I think is really interesting is, like, here's what the example was trained on, and you would say, like, okay, it must be able to, like, create some birds, right? Like, that seems pretty reasonable. And this is probably the model that is in Runway, but, like, a photo of homemade swirly pasta with broccoli, carrots, and onions, like, that's not a good representation of any of those things. But that might be better than me putting in a bunch of random words, right? So some of this is, like, if you learn what the model was trained on, you can get better results. So for example, if Runway had the bird model, we could probably generate pretty decent birds. Runway doesn't exactly have that model, so we're actually working from a different model. And I'll talk a little bit about what that means in a minute. But essentially, like, understanding this stuff requires not just, like, playing with the model, but sometimes it requires reading about the paper, about what the researchers were trying to do with it, and what they tried to achieve with it. So it's a really interesting way in which, like, it is hard to understand this stuff. You can't just jump in Runway and play with the model and expect to create great images out of it immediately. You might have to come in here and read some paper and, like, skip all the math sections or highlight some words that you have no idea what they mean and look them up on Google and get even further confused. And then you just like give up and like just start using Runway more. So this is like the initial like thing I want you to start to understand is that like this stuff is hard, it is confusing. So don't be frustrated if in the first minute you don't get it. But like we'll walk through some of the ways in which we might approach things and understand a little bit more. All right, thank you for indulging me with that. I'm going to jump back to the slides and do some more presentation. I think it's always helpful to like start with like just like a what is ML, what is machine learning sort of representation. So this is like the highest 10-minute session that I can run about like what is machine learning. I'm skipping over a lot. I'm making analogies about a ton of stuff, but hopefully it like helps you to get you thinking about how things work. Okay, so everyone's assumption about AI, like I talked about before, is that it's going to take over the world. These big Terminator machines are going to start to kill humans. And as we saw today, we're really, 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 really far away from that, right? Like, can't even convert text into a decent image. So there's no way we can expect Terminator to take over. So when a lot of people talk about AI, they talk about a thing called general AI. General AI is robots, it's supercomputers, and it's straight up fiction. Like, no person that is actually working in machine learning today thinks that general AI is actually possible, even in like the next 100 years. Like it just turns out that like having a machine that is as smart as a human is just really, really, really hard, and probably not going to happen unless some like revolutionary thing happens in the next decade or whatever. So what we're talking about in this class is we're talking about what's called narrow AI, and narrow AI is code that does one thing really well. And sometimes it doesn't even do it really well. Sometimes it just tries to do it, right? So that was like AttnGAN, which tries to convert text into images. Another example of narrow AI is horse to zebra, which we'll talk a little bit more about later. But this converts, like its whole job is to convert a horse image into a zebra image. That's it. That's all it does. So like when we talk about narrow AI, we're talking about like a very, very narrow use case. So again, like, when people talk about AI, like being able to do all these magical big things, they're really not. They're probably talking about like how maybe a couple different models are taking over like small bits and pieces of work. And maybe you add enough of those together that it feels pretty magical, considering if you don't understand how it works. So like, again, this is sort of reset our expectations. It's also important to talk about, there's two different types of models of machine learning, especially when you take the like intro to machine learning classes. Most people will talk about what's called a discriminative model. That's a model that says, it's what's called classification. It says, is this image an image of a cat, like what Jessica's hanging out with, versus a dog? So like, is this a cat? Is it a dog? Is it a horse? Is it a zebra? Those sort of things. So like, you will often see that people will do intros to machine learning and learning to make a model using classification. What we're going to talk about in this class is generative modeling. This is creating images of cats or dogs from other images of cats or dogs. And we won't just be doing cats or dogs, although I do promise we'll do at least one cat thing. So like, it's also important to start to learn that terminology, right? Because a lot of people are working in discriminative modeling because it's like, this is what Facebook tries to do, right? A lot of there is like, is there porn in this image? Is there not porn in this image? Is this a hate speech type of post? Is it not hate speech? Like this is what a lot of machine learning is focused on right now because it's helping to reduce workload on humans. Whereas what we're doing is generative modeling. It's much weirder. It's much more experimental, and there's a lot less solid business use cases for it, which is why we're going to have fun with it. So there's a lot more terminology around deep learning, and I used to try to teach every single phrase or term. And I just like, it ends up not being necessary for this class. But if you are interested in more of it, I have a slide, a full slide deck and a video that goes into some of the terminology that you're welcome to look into. But I think like starting at those level, that's like enough for you to know. So general AI, narrow AI, discriminative versus generative models. So again, like the 10-minute version of how does machine learning work? So if I were to ask you to draw a line that best represents this, this is the only math in this class, I promise. If I were to ask you to draw a line that like best represents these dots, you could pretty easily do that, right? You would draw it kind of like from the bottom left to the top right, and it would, represent this. You know, this is pretty basic like math that a lot of us probably did in maybe high school, maybe middle school. I don't remember exactly. So like this is all machine learning is. It's just this on like hyper speed. So literally when you do this, you do it a lot more, and you get really interesting images. This joke never lands, even though I try. It's like supposed to be like how to draw an owl, but it like never works. Also, it's like hard. Like I see people smiling, but I don't know if they're laughing or they're just like, man, this dude's a dork. But anyway, like this is literally it. So a lot of times when we're talking about like all the crazy complicated stuff that machine learning does, a lot of it is literally based on like taking averages or trying to figure out best fit lines to a bunch of data. And we'll talk a lot more about data sets next week. But if you hear a lot about people talking about big data, this is why, because you know, here are 5 points of images, or like, let's say here are 5 points of data. In this case, it happens to be between 0.5 and 0.5. It's sort of X and Y coordinates almost. But if I were to get this for 1 million samples, like then I would actually like maybe not draw a straight line. I might draw like a curved line or something similar to that. And that's sort of what machine learning is. And like it's that like plus way more. But in reality, this is the basics of it. So your data is really important because let's say the data that I was providing it actually like made a line from the top left to the bottom right. Like that would be a totally different data set or totally different data. And that's like the basics of machine learning, like right there, is that it tries to determine the best fit for the amount of data you've given it. What we're talking about is a thing called deep learning. So in some modeling, this is a level of like machine learning, right? Telling a machine to figure out how best to create this line is actually machine learning. We might find that kind of silly, but again, depending on how much data we have, like it actually like is really machine learning. Deep learning is a thing that involves layers. So that's it. When you hear people talk about deep learning, all they're talking about is that there's these layers here that represent different things. So in the case of images, this is a classification model or a discriminative model. In the case of us trying to figure out if this is a dog or a cat or what type of dog it might be, the way this works is that it goes through it converts all of these images to pixels. It then combines some of those pixels to figure out edges. So maybe it figures out the way the tail is shaped. It figures out the way an ear is shaped, or just like actually it figures out just straight lines. And then in the next layer, it starts to combine those things. So maybe you get this line, a little bit of a curve in this line, and then you start to get a tail. And then you combine those again, and you get a bigger and bigger features. This is how this is how almost all image networks work, right? Is they just start with a line of pixels, then they get a couple of features from there. They get more complex features until they get really complex features that they can figure out if it's a dog face or a cat face. We as humans probably don't do that. Like we don't instinctively do that, right? If I were to show you an animal you'd never seen before and say like, is this a dog or is this a cat? You would sort of instinctively say like, well, what is its nose shape like? What are its ears shaped like? How tall is it? How big is it? Those sort of things. So when we talk about like machine learning being similar to human learning, it is sort of in a way, but it's more of an analogy than anything else. So what do these layers look like? This is exactly what these layers look like. This is if you hear the term convolution, these are what convolutions are. These convolutions are looking for things. So basically this passes over an image step by step. If you can think of an image as a grid and you pass these images over that grid, it will pick up certain things, what's called activate. So for example, this one is looking for like sort of these diagonal stripes in one direction, right? The one next to it is looking for diagonal stripes in the opposite direction. And when you add all those up, so basically when it activates, it sort of turns white in those areas. So when you add all those up, you start to get these next layer of features, right? So in this case, like this is a picture of Gene Kogan. So in the case of Gene, like different layers are showing different things. So like this one actually shows almost a good representation of his entire face. Whereas this one seems to be showing a little bit more of just like vertical images, vertical directions of him. And when you add these up further and further, then you get a better representation of what the machine sees. Now the machine doesn't know that all of these adding up to a face is a face. It just knows like I see all these features. And I think that you've told me that it's a face in the past, so I'm gonna guess it's a face again. And then the other thing to note is that like, so the first generative model came out in 2014, and it produced an image that was, I believe that's 36 by 36, maybe 64 by 64. And we're now up to a high resolution image of like, this is 1024 by 1024, maybe 2040. But anyway, like, so this has been in, I think this slide is probably from last year. So this is 5 years of development of a neural network and how we've gotten way, way better in generative modeling. So I expect like in the next 5 years to get even further resolution and probably get better and closer to fully realized humans, which this one's pretty damn close already. So that's all like basic about machine learning. So the next thing is, why do machine learning art? This is one of my favorite quotes from Alison Parrish. Alison mostly works in language. She's a poet. So she mostly works with machine learning around language. So we're not going to see a lot of her work here. But her thing is like, so her post here, I'll read it, is asking, can a computer generate Shakespeare, to me is less interesting than asking, what would Gertrude Stein have made with TensorFlow? She also like later mentions that she specifically called out Gertrude Stein because Gertrude Stein was most interested in formal like experiments with language. And this is like exactly why I'm teaching this class to you, right? Like, I'm not necessarily interested in, can a computer be an amazing painter? I'm interested in what you as designers and artists and photographers can do with these tools. So much of what we've seen today with these tools is what data scientists can do with them, right? So data scientists is interested in, how can I make the most realistic looking human face? You as a designer or artist is probably not interested in that. And that's what I want to explore. I want to explore what you as an individual can do with these tools that encourages your own work, right? So it's not just like, I'm going to do what other people do. It's like finding the way that it can be self-expressive for yourself. I've also sort of like started exploring this world of like, I've been reading a lot about early avant-garde artists and early avant-garde designers. And I'm particularly interested in like, I feel like right now we're at this space of where the tools have gotten just smart enough that we can start to make really interesting images, but not yet to a place of where we're like, we have really amazing tooling, right? So like, we're still in the early photogram era of like image making. We're not yet in the Photoshop era where we have this amazing tool set. So this is like me sort of like waxing poetic on some work of like Moholy-Nagy or Jorge Kepes compared to like other artists who are currently working in that world. And like, these are purely aesthetic, but like, I think it's actually like more about the moment of experimentation that we're in and how we can make really interesting work. So lastly, I'm going to talk about why we make machine learning art. I'm going to talk a little bit about why we might not. Here's a couple of things we're going to talk about throughout the class. And it's things to keep in mind. So it is very expensive. That is true to this day. You have paid a decent amount for this class, and some of that money is going to go to you getting your own servers to run things on. And we'll talk a little bit about why you have to have a server, but it's really expensive. I think I calculated last year that I spent about $3,000 in server fees. And that is not cheap for most. That's probably out of the realm of possibility for most artists. And I'm able to do it for a couple of reasons, but also mostly because I teach this class. So thank you, everyone. It's also time consuming. It is a really slow process right now. It gets faster like every 6 months, every year, general software computation types of things, but it is very slow. This is not a thing where you can expect like to have great images overnight or even like in an hour for most models. It's low resolution. So we talked a little bit about how like the highest resolution we have right now is 1024 by 1024. There's some models that get a little bit higher, but not really. So if you're a print artist and you want to make a really large print, this is going to be tricky for you. And there are some ways around it, but it's generally like never going to be as perfect as like making your own image in like with a camera or in Photoshop or in Illustrator, those sort of things. Secondly, like these two sort of go hand in hand, which is like, it is hands off. It's like in a way, like you're sort of almost working on conceptual art. Like you're sort of like handing things to a machine and hoping that what you gave it is what you're like, what the intention of what you're going to get back is what you actually get back. Most times you get stuff back and you're like, what the hell happened here? So there is sort of like depending on how your artwork applies intention, you may struggle a little bit with this. And secondly, I think it's like, this is really sort of built around generative thinking. So if you're looking for the machine to sort of play collaborator and create new ideas with you, you might find it really successful. If you're expecting the machine to do exactly what you want it to do, a la Photoshop, you will probably struggle with this a little bit. And that's okay. Sometimes you can just find things that you like and sort of stick with them. But sometimes there's a little bit of a struggle of like, I can't believe I spent 3 days training this thing. I didn't get back anything that I think is useful. What do I do? And then the last two are things I often hear from people, which is it's hard to know where to start. And there's very few examples for me to build off of. The reason you're in this class is to fix both of those. So hopefully by the end of this class, specifically, you can cross off both of those, or at least cross off the last one. And then after the end of the 4 weeks, you can cross off that second one. So hopefully we'll get there. I want to stop here before I jump into all the inspiration and see if there are any questions. Great. Thank you for people that shake their head. That helps. Cool. Okay. So I'm running a little behind on time. Do people want to do a break, or do we want to like move through this? All right. Do this for me. If put a thumbs up if you want to, if you're cool with not taking a break. Okay, cool. Thank you. I will try to have breaks next time. I think it's just because we had to do intros and some other stuff that I fell a little bit behind. So we'll power through. But next week I'll plan to have at least like a 5 or 10 minute break between everything, so people can get up and go to the bathroom, that sort of thing. Okay. So now I'm just going to jump through a bunch of examples of work. Each of these is tied to the model that we're probably going to work with in class. So if you see work you think is really interesting, maybe just make a mental note of what the model is. And then feel free to reach out to me or Leah or other folks after class, and I can just sort of make a note of who's interested in what, and that might change a little bit of our schedule. So I'm gonna start with StyleGAN. StyleGAN is the most popular model. I think it's the one that probably most people have seen work from. It tends to look like this. So this is, I'm gonna mute this guy real quick. Oops. So you've probably seen it. It is the model that is all the faces. It's crazy how realistic it is. It's surprising that you can generate faces like this from a machine. This is probably the one that most people have seen is like, wow, look at how close we are to having AI that can generate images, right? And the problem with this is like, it actually turns out that this is like maybe the easiest problem for us to solve for a variety of reasons. It turns out that the reason that this is really easy for us is because we've had a decade of us training imagery around faces. Like face detection is like a big industry. So it turns out we've already built a lot of technology that can do this well. And it also turns out faces aren't that different from each other. So like your eyes might be bigger or smaller a little bit. Your nose might be a little bit of a different shape. Your skin color might change a little bit. But like for a machine, like that's all pretty subtle to it. Like it can pretty easily learn all this stuff. Whereas if you apply this to other work, which I will show like some of my work, it actually is much harder for it to learn a diverse set of images. So I think it's really interesting that like this is sort of what everyone is like, wow, this is amazing, but it's actually the easiest example of things that a machine can learn. So this is, so now I'm gonna jump into some artwork. So this is artwork by an artist, a Japanese artist called Kishi Yuma. So this is an example of, I think, just essentially a very short video that he then broke into frames and trained the model on. And you'll see here that like what's really interesting is you can still sort of tell their hands, but there's a lot of distortions in it, right? And there's a lot of weirdness going on. But I also think it's like a pretty amazing, like it's still human in a way that I think those faces are meant to be, but it's also pretty artistic and showing like a place where there's like a gap in the way that this model can learn while still making really interesting imagery. One of the things you will often see that people are doing with these models is they are manipulating faces. Mario Klingemann, I'm going to show a ton of his work. He's just a really amazing artist that does a lot of stuff with machine learning. But basically, I'll talk more about StyleGAN next week and explicitly how this works. But essentially, within these models, you can start to find, again, that line of fit. So think about like anywhere someone is smiling, you place a dot, and then you draw a line through that. And then you understand like, this line represents faces or smiles, and then you can animate across that, that smile. So you can do really interesting things like looking at, whoops, looking at Mona Lisa and actually making her smile, right? Really interesting stuff. This is some of my work. So about 2 weeks ago, a month ago, StyleGAN 2 came out, which is a new version of the previous StyleGAN. So you're looking at on the left was the sort of the same data set trained on, or the two different models trained on the same data set. And you can see how much more remarkably textured and interesting this new model version is. So we'll be working in StyleGAN 2 in class next week. It's pretty much the same in terms of the training. It's a little slower, but not too much. But you get much better representation of the images. And you're gonna see how drastically different these two models are. So it's pretty amazing. Again, if you look at that sketch where things start at 64 pixels and they've got to 1024, like now we're getting to 1024 plus like so much better quality. So it's really interesting. There's a lot of stuff we can do in StyleGAN 2. People are also having a ton of fun doing what's called projection, which is finding an image, the closest image inside the StyleGAN model. And people are sticking faces like Mario in it. You'll also notice that like so much of machine learning art is like almost horror imagery. Like this gets really, really creepy at some point. Like it just gets really messed up. I shared this with a coworker and he was basically like, thanks, those are gonna be in my nightmares tonight. So it's pretty interesting stuff. We might not get to this in class, but I have some demos of this working if you're interested in learning how to do something like this. So the next model we're going to talk about is pix-to-pix. I'm actually not going to teach pix-to-pix in this class, but I think it's helpful to sort of understand how it works compared to MUNIT or CycleGAN, which I am going to teach. And if you're interested in learning more about this, like I can definitely send you some stuff as well as record a video for how it works. But I'll talk a little bit next week about why I try to shy away from pix-to-pix. But pix-to-pix essentially, so whereas StyleGAN is trying to generate new images from a data set of a bunch of the same images, right? So faces of humans, faces of flower, or like pictures of flowers, those sort of things. Pix-to-pix actually works with 2 image data sets. So it works with what's called paired imagery. So in this case, it can be something like a photograph of a satellite photo, and then also what the Google Maps representation of it is. Or you'll see a lot of work in pix-to-pix is done using what's called segmentation. So it takes a photo and then someone, probably an intern at some research facility, has to draw all those images into represented squares. So like this light blue is a window. This green is some sort of like, architectural detail. This blue is the door. And then, so it trains the mapping between those two relationships. So a really interesting one is day to night. So this is probably from like a highway camera, and they pulled an image of it at daytime and they pulled an image of it at nighttime. And once it learns how to translate those two together, it can then take new images of one or the other and convert it to the other one. So one of the things you'll see often is that black and white to color is really interesting to do. And it's pretty easy to do because what you do to generate this data set is you find a bunch of color images, you stick them in Photoshop and convert them to black and white, and now you have your pairs. You've got a black and white image and you've got a color image. So there's a lot of work done around converting old black and whites to color by training it with modern images. And there's a thing called Deoldify that someone is working on, which is trying to basically take old black and white photos and convert them to new color. So this is like a very intensive process to make these data sets, which is why I don't generally teach in this class. But it is a really interesting and very powerful tool. It's also something that's used in pretty much everyone's cameras today. So if you have a cell phone camera, it's pretty much how it generates really beautiful photos. So I know this is how portrait mode works. So basically the way this works is that they can take, like in this case, they can take a very like night color with a lot of green cast, and then they can take a color photo. Actually what they probably do is the reverse, right? They find a really, really good photo, they cast it to green, and then they train it, and then you can do the reverse. You can take a green cast photo and convert it to color. So most of the software on your phone uses machine learning to produce really great images. I don't know if anyone ever played with this. There's gonna be a lot of cat examples because it's the internet. But if anyone ever played this was called Edges to Cats. And what you could do is you could draw an image of a cat, and then you could hit process and it would turn it into a real cat image. And the way they did this is by reverse training it. They would find pictures of cats, they would draw them in outlines, they would give them edges, they would train those two together, and then you can draw new cats. Or if you're a disturbed human being, you can also do this. So you can take a little sketch of a weird kind of cat-like animal and then process it through Pix2Pix to generate a disgusting horror show. But yeah, so like, again, like this is where art comes into play, right? Like if I want to train it on this data, but then I want to do something different with it, ImageStax will output. And this is where it kind of takes a little bit of a leap of connection that artists and designers are so good at to make that leap and make that connection. This is Scott Eaton. Scott Eaton happens to be both a visual effects artist and a really amazing artist who draws a lot of figurative art. So this is a case of where, like, back to Alison Parrish example, where it's like, I want to see what amazing artists can do with these tools. This is a perfect example. Scott has like a 45-minute video where he explains his process for these things. He happens to have access to like a photo studio. So he brought in models for probably at least a week, photographed them in perfectly like rendered lighting, also in all the same lighting. And then he drew all of them almost like Pix2Pix, like the Edges to Cats version. He then drew all of them, and that was what he trained it on. And now he's making these like very abstract, like they're human bodies, but in a very distorted perspective. Just a perfect example of someone who has like the perfect skill set to make a model like this that does something new. So I think the video to his work is linked in here in the notes, which I'll share with everyone after class. And then this is a pretty new thing from NVIDIA. This is called GAN. Some is called Spade, depending on what model you're using. And this takes sort of that similar idea, but does it fully in color. So each of these colors represents a different element. So essentially what's happening here is, so whoever's drawing this is able to apply different models. So every time you're clicking on one of these things on the right, as a newly trained model with these sort of segmentations built into it. So again, segmenting is like a pretty common thing you'll see here, but it allows you to make pretty realistic images from this. So I've seen a lot of artists in the gaming world use this as a way to start like basically like generating scenes for imagery and for games. It's a pretty interesting concept, and the reason NVIDIA is involved in it is because obviously, like, as someone who makes a lot of gaming engines and those sort of things, they can sort of build tools for gamers as well to do some really interesting work. A lot of stuff going on in gaming around machine learning because so much of what an artist's job at a game company is to generate scenes and to generate textures and these sort of things. So if you can start to generate that using machine learning, you can have less artists, which is kind of dark, but like that's part of what they're thinking about. So CycleGAN and MUNIT is what I will be teaching in this class. CycleGAN is different from Pix2Pix in that it still has two different folders of images, but those images are not one-to-one pairings, right? So it's not an image plus the outlines of those shapes. It's actually just two different folder sets, and it learns from that, which is pretty crazy to think about. Like from a conceptual standpoint, that's pretty hard for a machine to do, but it actually works out pretty well. So this is actually a case of where they took winter photos and summer photos that were not the same location. And they said, the model has to learn how to translate these two. And it was surprisingly good at doing it, right? Like if you look at this, you'll see that, it can take summer images and it can add, wintry stuff to it. It learns that like, oh, the way to do this is you add some white to the mountain ranges, or you make the ground entirely white. In the case of this water scene, I think it's pretty interesting. It still learns to like generate ice, like those sort of things. So this is really, really fascinating. And a lot of people work with this model because it's a lot more flexible in the terms of the way the data works. So again, data sets are like the big thing for all of machine learning, and understanding what the data requires and also understanding how flexible it is really helpful to understanding how to work with a model. I show horses and zebras all the time. It just happens to be like the de facto CycleGAN model to show. But again, they just took photos of horses and photos of zebras, and they said, model, go figure out how to translate these to one another. So what I think is really interesting here is you'll see that the ground is like a little muddier. It's a little like dustier, and that's because zebras tend to be in areas where there's more desert, right? So like the model even learned that it probably needs to change the background to actually make a horse to a zebra. And that's, again, like one of the things that we start to learn about machine learning is it's not just like, from our perspective, might say like, I want you to learn just how to convert a horse to a zebra. But what it actually learns is other things that are part of the scene. And that's called entanglement. And that's something we'll run into in a lot of places. But it's really interesting that like, it learns stuff that we might not expect it to learn, or it learns stuff we didn't want it to learn. And now we have to figure out how to undo that. So it's really important to keep that in mind. Yeah.
We have a question from Juliet.
Cool.
She asked, what does GAN stand for?
Oh, GAN stands for Generative Adversarial Network, which I'll get into a little bit next week. But obviously the G is important because that means it's generative. It means it makes images. And then we'll talk about the adversarial network part next week. But that's essentially like part of it. And that's how these things learn, is the adversarial port, which we will talk about next week. So there's also, what I love about CycleGAN is people just throw really weird things at it. So this is faces to ramen. So this is someone who has converted ramen to faces and then faces to ramen. And this is actually a really great example of how CycleGAN works, which I'll talk about in week 3. But basically, CycleGAN works almost like Google Translate. It tries to translate A to B and then B back to A. And the way it learns is how these two outside images connect, right? So how good is this output versus this one? And then we just happen to get the middle image as a bonus, which is what a lot of us will focus on, is what these images look like. But the way the model is actually trying to learn is by representing these two different spaces. So it's actually looking at how the face and the other face worked. This is Helena Sarin. She's probably one of the most prolific CycleGAN artists in the world. If you follow her on Twitter, she posts new images pretty much daily, if not hourly. And I think what's really interesting about her work is she's really interested in exploring what you can do with small data sets. So again, we'll talk about this more next week, but the size of your data set usually matters a lot, especially in stuff like StyleGAN. You need a lot of images to be able to train a decent model. In CycleGAN, it's a little more flexible. You can have a few less images. Like when I say a few less, it's like maybe 200 images in each folder. And by folders, I mean like A and B. So the two domains that we're talking about. But I know Helena works a lot with like much smaller data sets, and she still produces some really amazing images. And we're going to talk a little bit more about like what happens when you use smaller data sets versus larger data sets in a couple weeks as we work through our models. But she just creates a ton of images, and they're always fascinating. I may not love every one of them, but I always find something really interesting. And quite honestly, I have no idea what she's training this stuff on at this point. I think she's also doing like some really great feedback where she's like sticking old images from previous training sessions into new stuff and just producing really great work. She's very prolific and a really fun person to follow if you're interested in following artists on Twitter or Instagram. This is some of my own work. You'll see I often work with like vintage images, and I'll explain a little bit why later when I get into data sets. But this is, I trained a StyleGAN model to produce, I basically combined vintage illustrations of birds and vintage illustrations of flowers, and this is what I got. So the top here is where you're combining, you're giving an input of a bird, and it's kind of like camouflaging the bird in these flowers. And when you give it an input of a flower, it converts all of the leaves and other things into like feathers. So it's, again, it's like you get really unexpected things with CycleGAN. And I think that's why like so many artists tend to flock to it, because it just produces very weird imagery, but also very interesting work. And so this is, so CycleGAN, the reason I'm teaching CycleGAN versus MUNIT, I'll talk a little bit more about this again when I get to MUNIT, but MUNIT produces what's called multimodal, which just means you get more options. So this is an example of what MUNIT does. This is the same input image, and your output that you get from it are varying images, right? So in some ways, this might look like it's just purely colorization. It's just returning a different color. But if you actually look closely, you're getting different types of textures, right? So especially something like here, where you're getting a lot of like detailed dark texture, here you're not seeing as much of it. And here you're seeing a little, it's like a different variation. So MUNIT is like really cool because you get more options out of it. So I think, I forget who was talking about like how they want to produce more imagery and then curate it from there. that's why I'm going to start working with MUNIT more for this class, because you get a little bit more out of it. You get a little more bang for your buck, and you get more interesting opportunities to play with stuff. It's a pretty interesting model. Lastly, I want to show Memo Acton's piece. I can't show all of it, but it's like one of my favorite pieces. And I think he said he uses pix-to-pix for this, but I would probably recommend using CycleGAN nowadays. But I'll just play it and you can enjoy it. And there's, I think, another 10 minutes of this, and it also switches up a little bit. But what I love about this is just how simple it is, but how beautiful the output is, right? Like, so if you're only to see the thing on the right, you would still find it really, really fascinating, even if you had no idea how it was produced. But knowing how it's produced is also like, just adds another level of amazing to it, right? Like with such simple household items, he was able to create a network that could build these like amazing images. And if you were to do this today with newer software, this is probably 2 or 3 years old now, it would probably look even better. And I think that's just really fascinating and really like lo-fi creativity to do really great work. This is something I hope that we can all take some inspiration from. Okay, next stream prediction. Next stream prediction is actually just a like subset of pix-to-pix. It's essentially the idea of, so instead of your data set being cats and then the cat shapes, just the line outlines of the cat, it actually uses video. And it says, it pairs frame number 1 with frame number 2. Then it takes frame number 2 and pairs it with frame number 3. So it's trying to learn how motion works. It's trying to learn how, literally how the next frame of video should look. There's another piece from Mario Klingemann. So this is obviously trained on fireworks, but what I think is interesting is like, it kind of understands fireworks. It understands that they like explode from a point, but it like doesn't understand the actual physics of it, right? So again, here we're sort of exploiting like the dumbness of these machines to produce really interesting and kind of thought-provoking work about like maybe the science of these things. This is Jonathan Fly, who's another great person to follow on Twitter. He posts a ton of work. And here, oops, why does it keep doing that? This is obviously trained on a roller coaster, and we're going to get some pretty trippy results pretty soon. And then here's a piece that I trained for the first artificial images class. And so what you kind of learn is like, it learns a little bit about motion, but it doesn't learn enough to actually recreate it well. So I actually have had a couple times where I've trained it on a new video, and it's actually reproduced the video almost perfectly, and I've been really disappointed. Like I spent 3 days training something, and it like just reproduced the image, and I was like, what the hell? Why did I even waste my time here? So it just depends. If you want really glitchy stuff, next stream prediction is like a perfect place to look at work. This is a current thing I'm working on. This is trained on, again, early avant-garde art. So if you're familiar with like 30s early motion pieces or early like video pieces, this is trained on the same thing. It kind of learned it, it kind of didn't, but I still think it's pretty amazing. Okay, so SinGAN, we're stepping a little bit away from like video pieces. SinGAN is like a pretty new model, and I'm just starting to explore the artistic possibilities within it. Google, I think some people from Google Israel made it, maybe 5 or 6 months ago, and I think people are still sort of trying to figure out how to use it, which is like part of the artistic side of this work is like you can jump on a new model and like figure out how to make it artistic. And then other people will sort of adopt similar ideas or that sort of thing. So this is, I think, only, okay, so here's how, again, we'll talk about this next week with more data set stuff, but what's really interesting about this model is it only needs one image as an input or as a data set, which is like huge because like so much of our work requires thousands upon thousands of images that to only need one image to produce more images is pretty amazing. So what it does is this is the single image that it inputs, and then it like changes the output of an image, right? So if you look here, this is the mountain range. The mountain range changes a lot. And it does even learn that like, you know, what reflection in water should look like. So it's kind of understanding mirroring too. In this image, it's a bunch of birds. You'll see that you get different flocks of birds, different layering effects, those sort of things. What I think is sort of interesting about this model is it's a Swiss Army knife sort of thing. It does a lot of different stuff. And it does a lot of different stuff in different ways. So if you're interested in like playing with it, like I'm interested in sort of trying to figure out like if we can learn more artistic representations of it, but it's kind of like Photoshop for machine learning. There's like a bunch of different ways to like manipulate this thing. There's also a way to create animation using it. So basically like you give it a single frame and it creates animation from it, which is pretty interesting. Most papers have like a thing about like what doesn't work in it. And those are my favorite things to look at. These are examples of images that they were like, oh, it failed. And I'm like, yes, this is what I want to do. Like, look at these faces and look at how weird they are. There's a little bit of, once I talk about the model, you'll understand what these notations sort of mean. But basically what it means is like, there's a setting that gets you really weird images, and there's a setting that gets you pretty realistic images. And if you're an artist, you probably want to work in this range. If you're interested in reproducing like brand new images or really good images, you probably want this range. But this is a way of like, they buried this in the paper. Like it's actually in a supplementary paper that isn't the main paper that they linked to. And when artists started finding this, they're like, oh, there's actually potential here for this thing to use this thing in a weird way. But the people who produced this work didn't really want to talk about it, which is interesting to me. Here's some of my work working with it. This is an example of animation. So I fed it one image, and this is what it produced out of that image. So it produces sort of a way of like remanipulating the shapes. There's also a thing where you can produce a bunch of new images from it. So this is again an abstract image I fed it. It then produces like tons and tons of new images. So this is kind of interesting if you are like if you work in abstract and you just want to see new possibilities for your image, or you just want to curate a new image. This is like a really interesting model to create a bunch of new images from. That's pretty much it I have for SinGAN, because like I just haven't seen a lot of people work with it yet, but I think it has some potential to be interesting. Last thing we're going to talk about is StyleTransfer. You probably know StyleTransfer as something that does this. You will see a ton of examples and a ton of iOS apps and free apps online to convert your selfies into Starry Night or into Kandinsky's or other things. I think, unfortunately, this kind of became like the fart app of machine learning, and that it just became the thing that everyone is like, oh yeah, you can do StyleTransfer, that's cool, whatever. I think that because it became so cliche so quickly that it like artists sort of gave up on it. They're like, everyone's sort of seen this work. But I do think there's ways to do StyleTransfer that is really interesting and really artistic, and I want to show some of that work now. Mike Tyka is another guy who you might want to look up if you're really interested in machine learning. He is one of the people that invented Deep Dream, which I will not talk about here as much, but like you can look it up and you'll probably recognize it immediately. But he was at Google when they invented Deep Dream. He's done a lot of stuff around, he did maybe a year's worth of work in StyleTransfer and sort of experimenting with it. I think you can get some really interesting abstract portraiture. You can also, again, sort of like SinGAN, get some just really interesting iterations on things. So some really interesting work to be done there. This was my first experience with machine learning, where I just fed, like an online site a bunch of letters in Helvetica, and then also like some textures that I've been producing as a generative artist. And you get these really interesting sort of explorations into things. Like, I don't know if this would actually become an alphabet, but I think it's interesting texturally and an interesting way to start to think about how design might use some of these tools. This is some of my more recent work using StyleTransfer. Good StyleTransfer models, the one especially that we'll work with, also allow you to implement multiple textures at once. So you'll see here that you get this dotted texture in some places, you get this very like flowy texture in other places. And this is where the creative potential can come unlocked, right? It's not just like stealing Starry Night and applying Starry Night to an image, but it's actually like, maybe you take your own texture as an artist and apply that to an image, or maybe you find other, images you like and mash them together in a way. And I think there's still some real artistic potential in StyleTransfer, but it's just sort of like become a cliche that a lot of people avoid working in it. There's also some interesting options in that you can play with color, you can choose not to play with color. Again, a good model like the one we're going to work with is like pretty interesting, allows you to give you a lot of flexibility. You can also do video with StyleTransfer. I don't know I forget who this person is, but they just make really, really amazing StyleTransfer video. Producing video using StyleTransfer is actually pretty hard. I have the steps for it if anyone wants to do it. It just takes a while for training for multiple reasons, but it's still pretty fascinating to see this stuff applied in video as well. And then lastly, this is some experimenting I did maybe a couple of months ago, which is taking a StyleTransfer video and applying it to a static image. So here again, this is a technique where you basically, you can take video from one piece or from a video and apply sort of the flow. We'll talk a little bit about flow, but basically how the motion from that video works, how the thing moves, and apply it to a static image. So this is again like ways in which I think StyleTransfer could be exploited a little bit more. That I think it just became it became the fart app. It was like really cool for like a week and then it died. And I think there's still like a lot of exploration we can do within this. So that's sort of it for the models. What I want to talk a little bit more about is just how we use these things and what the future of these might hold. So I've sort of shown like individual models, but what I'm actually really interested in is how we can chain these things together. So this is a thing I just produced. So I'm going to teach another version of this class in New York City, starting at the end of February. So I produced this little promo video for the studio that's going to be hosting the space. And so what this is this is StyleGAN run through MUNIT. So basically StyleGAN produces the video, the interpolation video, and then I use MUNIT to provide textures to this thing. So what's really interesting here is this is actually Oprah transferring into Jennifer Aniston, into Bruce Willis, into Britney Spears, back to Oprah. Which is like the 4 celebrities that the studio was really excited about. So I just went ahead and did it. But again, like this is combining 2 models. So that's something to think about too, is you don't just have to stop with one model. You can like chain a bunch of models together. This is Mario Klingeman's work. This is like advanced level and nothing that I will be showing in this class. But what he's doing is he's taking a pix-to-pix network and he's doing face recognition. So if you've ever seen face recognition where you can see the shapes of people, like the outlines of their body, he's feeding that into this network and then like kind of ping-ponging back and forth, and it produces these really like distorted people as it tries to map the facial textures of things and as it moves around. So again, this is kind of chaining 2 models together to produce one result. This is Sophia Crespo. This is StyleGAN, but this is StyleGAN then produced to cyanotypes. So if you're really interested in just producing images, like this is also a way that like could be really interesting. You could produce an image, you could convert it to like print it on like a transparency or something, and then like do something like a cyanotype with it. So again, there's also really interesting ways to produce these images from it. And it also has this like vintage feel while also being trained on like weird insects and animals and flowers, and like there's all these weird textures. It has like this kind of like gothic horror feel to it that I think is really interesting. This is David Young. So David Young did a thing where he produced an image in a GAN, and then he sent it off to one of those like offshore painter facilities, which I don't know if anyone has seen, but like you send them a photo and they paint the photo and they send it back. So he sent them one of his machine learning images. He got the machine learning image painted, and then he has a painting of his machine learning image. And I think what's really interesting here is obviously this like goes through the computer vision learning algorithm to produce this thing. And then it goes through a human that has been like, you know, is offshore and doesn't really have a whole lot of like, I doubt David gave him too much of like an direction. So there's subtle differences in this thing, right? Like different colors, different shapes. The artist itself like sort of made some decisions around colors and what to remove and what not to. So again, this is a way that like you can think about these machine learning models as just the start of another project, or like just the inspiration for another piece of art. This is Robbie Barrett and his collaborator Mushbu. That's his name on Twitter. I don't know what his real name is or her real name. They trained a GAN on a bunch of fashion images. And what they came up with was this. They thought this image was really cool, and they said, wouldn't it be cool if you had a big bucket on your pants? They then went to and found a clothes maker to make a prototype of it. They then showed this in a show where they made a bunch of prototypes of clothing. And then Acne Studios just this week released work with Robbie that is fashion clothing produced inspired by the GANs that Robbie had made. So like this is the like end-to-end like really amazing journey of someone made a GAN and like they are in like a fashion runway show from like a very famous fashion house, right? And what I think is really, really interesting is if this this first image here, what this actually is they went back through the sort of the training data. And what they found is this was a purse. So if you imagine a fashion show, someone walking along with their purse, and like this was a bag. And the machine learning model basically decided like, I'm gonna remove the handle. And so now there's a bag strapped to someone's leg. So again, it's like they found a way to exploit the machine learning model's like stupidity and made really interesting pieces from it. And they kept up with it until they ended up with like this amazing runway show that is, you know, gonna be shown in Paris and other places. So again, I think it's really important that we as designers and artists who like already have a workflow and already have our own outputs, like think about how we can use machine learning as just another step in that process. So it's not like this is the end of our work, but it's just a way to generate more ideas and to create more possibilities for our own work. All right, that's it for inspiration. Are there any questions from anyone before I move on to our setup stuff? Seeing shaking faces. Okay, cool. All right. Feel free if you, go ahead.
I kind of have a question about some of the video ones. Like,
yeah,
maybe this is too computer sciencey, I don't know. Are they stateful to make them look smooth? Like, does it remember what happened in the frame before, or just by how it always interprets the frame, they look very smooth, how they move between each other?
So it depends on the model. So for example, if you look at this piece, so this piece, like it's not very smooth, right? It sort of bounces around a lot. And that's because of the way I made it. It only looks at one frame at a time and it doesn't remember the frame before it. In the case of this piece, this one, there is a state that it has to take from the previous frames. So part of the reason why this stuff takes a long time to produce is because it does have to look at the previous frame, and it does a thing called, what's called a flow. So before you even do the style transfer, it looks at all the video and tries to understand where things change and where things don't. And then it then when you're doing the style transfer, it only trains in the areas where things have changed. So that's how it keeps like a state that is pretty static. So some models have that built in, others don't. Others you have to find hacks around it. Like there's probably a way that I could have done some of that here, but I just chose not to, for partly because this was like a quick promo project. But yeah, some of that stuff you have to build in and some of it you don't. So yeah. Any other questions? Cool, I'm just gonna do a quick time check here. All right, so we have 20 minutes left. So I might go a little over today, and hopefully I won't going forward, but if anyone needs to drop off beforehand, that's totally fine. What I wanna do today is I just wanna get us set up for a couple of things. So the tools we're gonna use in this class today, we're gonna use a thing called Paperspace. we're going to use a thing called Runway, which I demoed really quickly today. And we'll talk a little bit more about today. We're also going to use the terminal. I know like the terminal is like the scariest thing to non-coders, but I promise we'll make it pretty, we'll make it as painless as possible. I won't promise there won't be a little bit of frustration, but we'll try to make it as easy as we can. And then we're also going to use a thing called Colab. Colab is a thing from Google. It's built on, if you're familiar with Python, it's built on Python notebooks. It's a really nice way for me to provide some instruction and step-by-step things for some of the work we're doing. So it's really helpful to just sort of like, I hope it's a helpful learning tool. This is the first time I'm teaching using it, so we'll see how it goes, and you should give me feedback on how you feel about it. There's additional optional tools that you can use in this class. You don't need to, but sometimes I find it's helpful. An FTP client is really helpful for you to upload files and download files from your Paperspace server. I'll show you how to set that up, but I generally use a thing called Transmit, which is a FTP you have to pay for. I think it's like $60 as a one-time license. If you want a free version, there's a thing called CyberDuck. That's probably the most popular. CyberDuck is fine. It works fine. There's nothing wrong with it. Transmit's a little bit nicer, but maybe not $60 nicer. So it's up to you if you want to use that. There are other ways to get your files up and down from the computer. It just is a little bit more painful to do it. Photoshop, if you want to like edit stuff, both for your data set and for other things, it's maybe good to use it. You can use whatever image editing software you want. There's a tool called Gigapixel AI that allows you to do higher resolution for your images. It's actually a machine learning model itself. And it does what's called super resolution. So it actually like makes an image higher resolution, and it's nicer than Photoshop, but it's still weird. So like it produces better images than Photoshop can, but it also kind of does their machine learning thing on them, and you'll get some weird textures. But if you're interested in like higher res printing, like that's a good solution. There's also some models in Runway that can do this as well, but Runway is a little bit more expensive. Gigapixel AI, I think you can do a free trial for 30 days and just see how you like it. And I think it's like $75 if you want to buy it. Just depends on if it fits into your flow, in your workflow. Lastly, while we're making data sets, a camera, a scanner, any sort of materials you have to produce new data sets are going to be helpful, but that's going to fit into how you want to work. So again, like feel free to use those tools, feel free to not, whatever you want to do. In this class, you will get $100 in Paperspace credits, and you'll get, I think, $30 in Runway credits. So basically when you sign up, you get $10 for free. Actually, it might be $20. It might only be $20, but that's enough to use. When you sign up, you get $10 for free. I have another coupon that I will post in the Slack after class that will get you another $10, maybe 20, I forget actually. But basically that'll be enough to do whatever you want to do in it. Runway is semi-expensive. It's 5 cents a minute when you're running a model. I'll show that in a little bit, just how it works. But be aware that like it is sort of pricey. What this money converts to in actual hours is this. So Paperspace is 78 cents an hour. That gets you about 4.5 days of compute time, which will get you at least one of the models. So if you want to do MUNIT, you can definitely do that. If you want to do StyleGAN, you might push it a little bit, but I think you can probably make it. And then it gets you about maybe 7 to 10 hours of Runway, which is plenty, especially for this class. But this is basically what you get. So like, remember, like this is a pretty expensive process. And there are ways to do it a little bit cheaper that I'll talk about maybe at the end of class in like week 4. But in general, like this is all you need for class. Like, let's just say that you shouldn't be having to pay more money for anything that we're working on. Unless you want to literally do every project twice, that's going to cost you extra money. But you should be good with what you've spent already in class. Okay, so a little bit about these things, again, to talk about price. So Colab is free. It's run by Google. Know that it's Google. So like what you upload to Google might be being tracked, but might be like, they may be tracking it. They might not be, who knows? Your feelings about Google's ethics are your own. And I'll say it's helpful to learn this way, but you don't have to use it if you don't want to. The problem with Colab is that it's kind of slow. It can be a little confusing. And it shuts off after 8 hours, which means it's really hard to train on it. So like StyleGAN takes about 3 days to train, and you need that full time to work on stuff. So like it's going to be really hard to do that in Colab. Paperspace, on the other hand, is really easy to set up. We'll probably run through this setup next week. just because I think we're going to run out of time this week. I have a video if anyone's really interested in jumping ahead of how to set it up. But basically, like, it's a pretty simple, straightforward process. It is, as I said, 78 cents an hour. For this class, I'm going to ask that you create a team and then you give me and Leah access to it. Just because that'll, like, it helps with us debugging in case you run into issues. And I'll run you through these steps next week. Runway. So it's great for exploring new models. There's a ton of models in there. It is expensive, so it's 5 cents a minute, which is just like absurdly expensive. But for what you do in Runway, it's great. And you can't really train stuff in Runway. So they just released training. It's also really expensive. And it only does StyleGAN, and it only does StyleGAN 1. So if you remember when I showed like the comparison between my like first version of flowers and my second version of flowers, it only does the first version. So like I really wouldn't recommend it unless you like just really want to train there and like are frustrated by using the terminal or other things. So I generally wouldn't recommend it, but I would recommend it for like looking at new models. You've got 2 pieces of homework. Your first piece of homework is to explore Runway. So literally like take 30 minutes and open up Runway, set up your account, install, like use your coupon code. And then I want you to just like find a model in sort of exploring Runway. Use those category features, do searches, look around. Find a model you like and just play with it. Try to make some images. There are some models that do text. So if you're interested in playing with text, feel free to do that. What I'd like you to do is if you decide to do this homework, that you post in Slack your exploration. So maybe you say like, hey, I was playing with this model. I think the inputs are this, this, and this, or like I play with the inputs by uploading some images. I made some outputs. Here's what they are. I saved the images. And then I also want you to talk about like what was confusing about it. What you will generally find with all machine learning models is they're all confusing. There's always something that they're like, I wasn't really clear like how this worked or how this thing did this thing, or like I actually didn't understand what the inputs were. Some of it might be Runway. If you have an actual Runway issue that you find or like have feedback for Runway folks, I will always give them good feedback. But this is your first assignment. This is the only thing that's like official homework. Your next assignment is to start thinking of a project. Ways that I would think about this project are based on what you saw today, you might just have seen something you're like, I want to output something exactly like that. Totally fine. That's how I work sometimes too. If I see someone making something, I'm like, how did they make that? I want to have an output like that too. A better way to think about it that I would encourage you to think about is like, what are like intrinsically inputs that I have available to me, right? So if we talk about Scott Eaton was an effects artist, meaning he has access to 3D rendering tools. He has access to a photo studio to do high resolution photos of artists. And he's like an amazingly skilled figure drawing artist. Like that's his skill set, right? So start to think about what your skill set is, and if there are ways in which you can see that fitting into some of the models that I've shown you today. It's totally fine if you're just like, I just want to play with faces or other things like that. But I would encourage you to start to think about like, what is your artistic practice and how do you think it might fit into what you're doing with the work? So this is really just start thinking of a project. You don't have to have a fully formed idea, but I just want you to start thinking about it a little bit. So Runway, play with Runway, stick some comments in Slack if you feel like it, and then start thinking about a project.